So I'm with you guys on page 4 right now. We're going to continue walking you guys through how to solve for x in our new unit. I want to remind you guys that we have taken a look at the bottom of page 3. Our previous unit was simplifying, and all we did was take a value and plug it in. And so for this first one, for example, we did 5 times 4 and got 20, and now we got 20 minus 6 to get the 14. So now on our new page, what we're doing is we've got the 5x minus 6 equals the 14. So I have now given you the total, and now we're going to work backwards to try to figure out what x has to equal. Now we already know from the bottom of page 3, again, we already know x is supposed to be a 4, so let's prove it. Okay, so since we have a 5 times x minus 6, the first thing we're going to do when working backwards is to cancel out this 6. So we're going to add 6, and we can cross this out now. That's a 0, but we don't have to write that down. And so I can just bring down the 5x right here. You don't have to write this little arrow. I'm just saying I'm bringing it down. And now we've got the 14 plus the 6 would be 20. So now we have 5 times some number equals 20, and 5 is our coefficient. So we're going to divide both sides by the coefficient. And remember, 5 divided by 5 is 1, and 1 times x is just x. And over here, now 20 divided by 5, we've now proven the 4. Now on your homework, you're going to have to check. And the check step is just in your previous unit of simplifying expressions. So if this says to check your answer, you've got your 5x minus 6 was the expression, and we now think x is 4. So you're simply going to plug it in. You're just going to plug in your answer. And 5 times 4 is 20. And then when we take away the 6, we do get 14. And that is the answer that we were supposed to get. Okay? So when you're checking your answers, all you're doing is just showing the work where you plug it in and it gets the total that you were supposed to get. All right, so now let's try the next one. We've got 3x minus 10 equals negative 16. Now previously already what we did here was we took a negative 2. We plugged it in right here. 3 times negative 2 is negative 6. And then when we took away 10, we got a negative 16. So now we're going to work backwards. If we know it's supposed to equal negative 16, and we have 3x minus 10, we're going to do the opposite of the constant. So we're going to add, and that cancels it out over here, and we're just going to bring down the 3x. On this side, negative 16 plus 10 is negative 6. And so now we know that 3 times some number is supposed to equal negative 6. So we're going to divide by 3 on this side to get x all by itself. And over here, 6 negative divided by 3 is going to be a negative 2. All right, so now we're just going to take the time once again to check our work. I want to just review how to check with you guys. So the check step is quite simple. We think x should be a negative 2, so we're going to do 3 times the negative 2. We're just going to plug it in. And then we've got minus 10. So here is our negative 6 and minus 10. And that is a negative 16, just like it should be. Okay? All right, cool. And now we're on the last one over here. Just showing you guys the transition from our last unit to our new unit. So in our last unit, we had an expression, 8x plus 40, and we plugged in a negative 6 right here. 8 times negative 6 was negative 48, and negative 48 plus 40 is my negative 8. So now we're going to be given the total of negative 8, and we're going to work backwards to solve for x. So the first thing we're going to do is get rid of the constant. If it's a positive 40, notice I subtract on both sides to cancel it out over here. 40 minus 40, now it's gone. And now I've got the 8x, and 8 negatives and 40 negatives is a negative 48 on this side. All right, so now we're going to divide both sides by the 8, divide by the 8, and x here will equal negative 6. We already know that should be the case because of page 3, but let's just check real quick by plugging it in right here. So we've got 8 times negative 6 is negative 48, and negative 48 plus 40 is in fact our negative 8. We're good to go. That checks out right there. Okay? All right. So we're going to scroll down now here, and for this mixed practice, notice I've gotten you guys started here. We've got the negative 5x plus 9 equals the 24. So my first step, we're going to just subtract 9. And we're going to bring down the negative 5x. And 24 minus 9 here is going to be a positive 15. Now for your next step, you're going to divide both sides by this coefficient. And now the coefficient of x is a 1 on this side. Negative divided by negative is positive 1, so we get just x over here. And here we've got 15 divided by a negative 5 is going to be a negative 3. All right, you can mentally check real quick by plugging it in. A negative times a negative is going to be a positive 15, and 15 plus 9 is 24. Now number 8, we got to be careful here. Notice that we switched the terms. You might remember from some Google Slides already that we boxed the terms in green. And so if it helps you to see this problem is really a negative 2x and then a plus 3, then what you would do is you would drop your line and you would say, okay, I've got a positive 3, so now I'm going to subtract 3. I'm going to subtract 3. So for number 8, the positive number just happens to be in the front of the expression. We've got the 3 minus the 2x. So just be careful. Let me actually erase the green boxes too. So you've got a positive 3 as your constant, so we subtract 3, and 3 minus 3 is 0, and now we're going to bring down a negative 2x. On this side, 21 minus 3 is 18. Now we're going to divide by this negative 2. We're going to divide by this negative 2, and x here equals negative 9. You can use your calculator along the way if you need to for the math on this side. And remember that on this side over here, what we're trying to do is just get x by itself. All right, and now for the last one, we have a negative constant, negative 3, so we're going to add 3 to cancel it out over here. And on this side, we have the addition property of equality that says if we add 3 over here, we got to add 3 over here. So 5 plus 3 is 8, and we have a negative 8x on this side that we're bringing down. So negative 8 times some number is 8. So to figure that number out, we're going to have a negative 8 over here, divided by a negative 8 over here. That cancels out, and x here would be negative 1. Okay? All right, mentally, let's just check real quick. Plug it in. Negative 8 times negative 1 is positive 8, and 8 plus 3 is 5. All right, so now we have some expressions here that have division involved. And so all of the problems so far have had a coefficient with a variable, and then we add or subtract a constant. Now in this new section, we're going to have denominators, okay? So just take notes along with me here for number 10. When we simplify when x equals negative 12, we plug in a negative 12 in the numerator, and then we do this negative 12 divided by 2. That's going to be my negative 6. All I got to do now is add the 5, and that's how I get negative 1. For the middle one, this one was done for you. We've got k equals 36, so you're going to plug it in. And now 36 divided by 3 is 12. Division comes before addition, so that's why we divided here first. And now we're going to add 15, and we get 27. Now for the u try, I'm going to just go ahead and do it with you. That's okay. We've got y equals negative 12, so we're going to plug it in the numerator. And now we've got a negative divided by a negative, and that's going to be a positive 4. And now 4 minus the 7 is a negative 3. So my goal is to now show you guys with the division how we undo that in solving the equations, okay? So now notice for number 10, I've got the negative 1. I'm now telling you the total is negative 1, and we're going to prove and right here and solve for x that it should be a negative 12. So the first thing we're going to do is drop the line. If the last thing we did here was add 5, it's going to be the first thing we do right here to undo that, and we're going to subtract 5 from both sides, and it cancels out right here. And we're going to bring down the x over 2 on this side. Now on this side, negative 1 minus 5 is a negative 6. So now what we're left with is some number when divided by 2, it equals a negative 6. So what's the opposite of division? We're going to multiply by a 2 over a 1 here. Multiply by a 2 over a 1. Now friendly reminder that anytime your denominator is 1, you don't have to write it. So you're not going to see me writing that a lot in my work. But I will, at least on this side, keep it over here to help you see that 2 times x is in the numerator, and then we divide it by 2 over here. So when you have 2x over 2, the 2's cancel out, and that's why x is all by itself on this side, okay? And then on this side, we're multiplying still by 2, and a negative times a positive, there's the negative 12 that we knew it should be. And we can see it should be a negative 12. Negative 12 divided by 2 is negative 6, and negative 6 plus our 5 would in fact be a negative 1. Okay? All right, so now let's try this one. We know we're trying to prove that k should be a 36. So first, we have a positive constant, so we're going to subtract to get rid of that. Now the constant is gone, and we're left with a k over 3. On this side, we got 27 minus 15, and that's going to be a 12. And since we have a denominator of 3, we're dividing by 3. We're going to do the opposite now and multiply both sides by 3. The 3 over 3 cancels out over here. 3 divided by 3 cancels out, and we're left with k. And on this side, the 12 times the 3 is our 36. Now for the last one here, we've got y divided by negative 3 minus 7 is supposed to equal a negative 3. So now to solve for y, we're going to add 7 for it to cancel out over here, and let's add 7 over here. That cancels out. We've got y divided by negative 3 equals positive 4. Negative 3 plus 7 is positive 4. Now, since our denominator is a negative 3 and we want it to cancel out, we're going to multiply by a negative 3 and multiply by a negative 3. That cancels out over here, and we're left with y equals, and we get our negative 12. Okay? So this video now just showed you with page 4, it reminded you that we're basically taking the old stuff we know how to do, simplifying expressions, and now we're just going to take the total answer and set it equal to that, and I've taught you how to work backwards and solve. So now let's flip over to page 5. And here I'm just going to kind of walk you guys through the work that you see. I encourage you to keep the video playing and just copy down and take notes with me along the way as I'm explaining what's going on. If you wanted to pause the video and just try it on your own, feel free. So for number 13, g divided by negative 5 minus 12 equals negative 6. So to cancel out the constant, I'm adding 12 to both sides. And negative 6 plus 12 is positive 6. Now, because my denominator is a negative 5, when I bring that down in my work, I'm going to multiply. And friendly reminder that this is technically over 1. So when you multiply numerator times numerator, you get a negative 5g. And over here, 1 times negative 5 is negative 5. And right there, the negative divided by the negative cancels out. So I actually never take the time to write all of that. I just put, if it's dividing by negative 5, I'm going to multiply by negative 5. And then I just cut it out like that. I just slash it out like that. And we have the multiplication property of equality that says what you do on one side over here, you got to do over here. And so 6 times the negative 5, we're going to get our negative 30. Now to check, all we're doing is taking the negative 30, plugging it in. We've got our negative 5 as a denominator. And now let's see what that problem said. It said a minus 12. So follow PEMDAS. Negative divided by a negative is positive 6. Now 6 minus 12, we're at a negative 6. And that is the total we should get. All right, so let's take a look at number 14. If the constant is a negative 8, we're going to add 8 to both sides so I can cancel it out. And on this side, negative 3 plus 8 is 5. That's where I got the 5. Now, since my denominator is 4, I'm multiplying both sides by a 4 right here. So r is all by itself, and 5 times 4 is my 20. You can check mentally. 20 divided by 4 is 5. And 5 minus 8 is a negative 3. All right, and now last but not least here for number 15, we've got z over negative 2, and we're going to add 16 to that, and it's supposed to equal 6. So what we're going to do now, positive 16, we're going to subtract to cancel it out. And on this side, 6 minus 16 is my negative 10. Now, because my denominator is negative 2, I'm going to multiply both sides by negative 2. And on this side, it cancels out. I bring down z. And on this side, a negative divided by a negative would be a positive 20. All right, so that takes care of me trying to show you guys how to show the work to solve for an unknown number. We're solving for a variable. All right. Remember when you guys saw this problem already? It was back in a video for page 7 of our last packet, and you guys had to simplify this expression given the radius of 3. And what you did was you had your formula for pi r squared, and we have pi is 3.14, the radius was 3, and we squared it. 3 squared happens first, and that's where I get 9, and then I multiply, and this is what we have been doing in our previous unit, simplifying for the total, okay? So that's what you did in your last unit. You simplified when given a value. But what if instead we're now given the total area and asked to find the radius? Notice that this bold question asks, what's the radius of a circle if we tell you the total area? So we've got our area formula, and notice that this time we've been given the total. I plug it in right there. I've got 3.14 for pi, and we're going to solve for r. Now, because we have a coefficient of 3.14, we're going to divide both sides so this can cancel out over here, and I'm just going to bring down the r squared in my work. Now on this side, if you do 28.26 and you divide it by the 3.14, we divide to get rid of coefficients, you're going to get a 9. So now let me ask you guys this. If the radius gets squared to be a 9, what is the square root of 9? Our radius would be a 3. Okay? Because 3 squared would be that 9. So in our geometry unit that's coming up, we're going to start out by me giving you the dimensions, and you're going to be finding total areas and volumes. But then we're going to try some where I give you the total area and ask you to find the missing dimension. That's when you're solving. Okay? All right, so now let me just scroll down, and let's try a rectangle problem. All right? So if the area of a rectangle is found using area is length times width, we want to know what the length of the rectangle would be if the area is 40 and the width is 8. So notice we've been given the area, so I plug that in for the area. We know that the width is 8, and I've just got a cursive L here so it doesn't look like a 1. Now remember right here, L times 8 is the same thing as 8 times L, and we usually write a coefficient in front of the variable. So that's why I just switched them around, and I have the commutative property that says I can do that. So we basically have 8 times some number equals 40. So we're going to divide by 8 and divide by 8, and that cancels out over here. L's all by itself, and we're going to get 40 divided by 8 would be a 5. And to check, obviously you've just got to do 8 times 5, and of course that area would be a 40. All right, let's try another one now. We've got a perimeter problem. So we have a perimeter of a rectangle. So you got a rectangle, okay? And when you add up all the sides, basically, you've got a length here and another length. And then you've got a width and another width. So it's saying, okay, you're going to take 2 of those lengths and add it to 2 of the widths, and that's why the formula works. So what it's asking us now is, what is this width? What we don't know is W. If the length is 10, so we've got a 10 here, this is a 10, and we know if we were to add them all up, it should be a 28. So notice I've given the total perimeter, and so now I've set it equal to 28. We know that the length is 10, so I've plugged in L for 10 right there. And now we're going to solve for W. Now first we can simplify. 2 times 10 is 20, and that's my constant. So what I'm going to do then, if my total perimeter here is 28, I'm going to take away the 20 that we already know is there in blue. And what that means is that in green, we have 2 widths. This width and this width, our 2 widths are left over, and that's going to total 8. So if we divide by the 2, that's going to cancel out, and we get here that the width would be 4. The width here is 4. And we can check by saying, okay, so if this is a 4 and this is a 4, that's 8, and 8 plus this 20 is our perimeter of 28. So we're going to be using our skills of solving equations in our geometry unit very, very soon to be both to find missing dimensions when given the total perimeter, or when given the total area, or given the total volume. And that concludes our videos for pages 4 and 5. Thank you.